I'm Anil Kumar, and in this video we will understand what are skew lines and we'll develop some equations for the planes containing skew lines. The question here is, consider the lines L1 xyz equals to 1 minus 2 4 plus s times 1 1 minus 3 and L2 xyz equals to 4 minus 2 0 plus s times 2 3 1. Determine the equation of the plane that contains L1 and is parallel to L2. So what we are saying here is that we want to find equation of the plane. Let's say this is the plane for us. We want to find equation of this plane which contains the line L1. Let's say that's the line L1 and is parallel to L2. So that means this plane is parallel to L2, right? So that is L2 for us. So that is the situation. So we have the other line L2 which is parallel to the plane containing L1, right? Now since this is in a parallel plane, so let me just kind of sketch one here which could be a parallel plane, right? So that could be a parallel plane. Since these two planes are parallel, lines will never intersect, and such lines are skew lines, right? So I hope that picture gives you a good concept of skew lines, right? And now let us see how to find equation of the plane which contains one of the lines and which is parallel to the other line, right? So let's call this plane as pi 1, okay. To find the equation of a plane, we need to find normal vector. So normal vector, now since these two planes are parallel, if I have a vector which is normal to this plane, I mean kind of like this, it has to be normal to the line also, correct? So that ensures that the normal is normal to both the planes and those planes are parallel, right? So I hope the concept is clear. Now how do you find a vector which is normal to two direction vectors? By cross product, correct? Straight, right? So we have here m1 which is 1 1 minus 3 and m2, the direction vector for these lines is 2 3 and 1, right? So these are two direction vectors. They are not equal, clearly they are not scalar multiples, but we can find the normal vector by cross product. So the normal vector will be equals to m1 cross m2. So once you do that, you get the normal vector. Okay, so if I get the normal vector, I can write down the equation of the plane. Let me write down general equation of the plane, which we are saying pi 1 will be ax plus by plus cz plus d equals to 0, right? So we'll keep this page, this side, as kind of references or concepts we are working with. So that will be the equation where a, b, c are normal, right? So where the normal vector will be a, b, c, right? So a, b, c, the coefficients in this form are actually normal vector. They are representing the normal vector, correct? So let's find the normal vector. So normal vector will be cross product of these two, which is 1 1 minus 3 cross 2 3 1, right? Now to do this cross product, you can adopt the method you have learned. I prefer to use this matrix method. So we have I, j, k. These are the unit vectors. And then we have 1, 1 minus 3, 2, 3, 1. And that gives us I as 1 times 1 minus this, which is plus 9 minus j. 1 times 1 minus 2 times minus 3, so that makes it 6, okay, plus k, which is 3 times 1, 3, take away 2 minus 2, right? So that gives us 10I minus 7j, and that is plus k, right? So from here we can write that the normal vector is 10 minus 7 and 1. Clear, right? Since the normal vector is this, the equation of the plane can now be written as, so a, b and c values are these respectively, so we can write this as 10x minus 7y plus 1z plus d equals to 0. So that becomes the equation of the plane, but we still need to find d. So how do you find d? To find d, we'll utilize the points. We need to find the equation of a plane that contains L1. So we need L1. So that really means that the point which is 1 minus 2, 4 should be on the plane. So the point which we are considering is 1 minus 2, 4 should be on the plane. So these are the values which I can substitute to find d, right? So taking this point into consideration, we have 10 times 1 minus 7 times minus 2 plus 4 plus d equals to 0, right? So that gives you 10 plus 14 plus 4 plus d equals to 0, which is 28 plus d equals to 0. So d is equals to minus 28. So once you get the value of d, you can write down the equation of the plane. So the plane which contains the line and which is parallel to the other line is, we'll substitute the value of d here now, right? So we have 10x minus 7y plus z, and d is minus 28 equals to 0, right? So that is the equation. So in the given condition, we found normal to be 10 minus 7, 1, and we found d to be equals to minus 28, and so the equation is as written here, right? So I hope the steps are absolutely clear, and in this example you kind of get an idea of skew lines and how to get equations which will relate them. I'm Anil Kumar, and I hope that helps. You can always share and subscribe my videos. Feel free to post questions. Thank you and all the best.